Hello everyone. Today we're going to talk about some trigonometric ratios. Um, they're called sine, let me put it on this, sine, cosine, and tangent. So basically these are defined based on a triangle. Let's say you have a triangle, you have a right angle, 90 degree, and based on what we're going to talk about, these adjacent, opposite, and hypotenuse legs, we are going to define what is going to be sine, cosine, and tangent. In a detailed numerical example, I will walk you through what exactly they are, how it's easier for us to remember them, basically these formulas, and how we can use them to figure out some unknown parameters in a triangle. Just bear with me. I'll in next slide I'm going to show you a couple examples. Okay, let's assume we have a triangle, and as I told you before, we have a right angle for sure, 90 degree, and whatever we're going to talk about in terms of sine, cosine, and tangent, based on the formulas that I'm going to explain here, they're going to be just for these two alpha and beta angles. We don't want to talk about these angle, the 90-degree angle for now. They are just about alpha and beta, okay? Let's just focus on alpha for now. And the same will happen for beta. So first of all, I'm gonna tell you, well, I'm gonna write it down again here, alpha. We know that we have three legs, right? So the opposite one is easy to remember. This is the opposite leg. And we have two basically legs that are creating alpha. One is always a smaller. Always one is a smaller, and that's called adjacent. And the other one, which is bigger, is always called hypotenuse. I'm going to show them with A, H, and op is okay. So for sine, and cosine, for now, we just focus on sine and cosine, we have a ratio. And there is 4 parameters in this ratio, right? On down here, it's always hypotenuse. Sine and cosine, they are always something divided by hypotenuse. But something sometimes is not easy to remember. These are either the adjacent or the opposite. Sometimes it's maybe we just mix them up, right? The way I try to remember that is like, because sine is in reality sine is opposite. I was like, what's up? And I just call that sup, right? And when you're using opposite here, the other one goes here. Okay, so in this example, sine is, let's say for example, if I have a triangle with 3, 4, and 5, and this is my alpha, if I want to calculate the sine of alpha was opposite over h, and opposite is the opposite leg, which is 3, and h is always the biggest leg in the triangle ever. The biggest one is 5. And for cosine was adjacent over h was 5, and adjacent is what? Is one of the legs which is creating that angle, but the smaller one. This is the smaller one. And this is sine and cosine. Okay, now let's go and see how we can calculate the tangent. Tangent is always sine divided by cosine. Okay, let's start by that. Sine was opposite over h. Cosine is adjacent over h, and these h can be cancelled. It's going to be opposite over adjacent. And for alpha, tangent alpha is opposite is 3, adjacent is 4. I think it's, well, that's, at least for me, it's easier to remember the opposite, how we can start to derive tangent and sine over cosine, and then we come down to opposite over adjacent. Okay. Okay, my question is, first of all, before this video, before you watching this video, what was confusing for you? What was making you confused the most between sine, cosine, and tangent? That's my first question. And second question is, the way that I was trying to remember that sine and cosine, which I was using that sup thing, did it help at all? Please comment the answers below here. And also, if you have any other questions, let me know down here. I'll try to get back to you as soon as possible. Have a good day.